In this video, we're going to look at graphs of polynomial functions. So previously, we've talked about graphs of quadratic functions. And what we're going to do is extend what we talked about there to polynomials. So first thing we're going to do is talk about the intercepts. Just like with the quadratic functions, we want to find the horizontal and vertical intercepts. Vertical intercept, that's easy. You plug in 0 for our input. But horizontal intercepts, those are a little bit more complicated. So we're going to kind of limit ourselves really to 3 different ways of looking at them. The first is the easiest, and that's when the polynomial is given to us factored. So the polynomial is in factored form. Then all we do is set those factors equal to 0, and we're done. Otherwise, we need to factor it. So it will be something that we can factor. Maybe we have to use greatest common factor, maybe the trial and error, difference of squares. You know, there's lots of different types of factoring. So we might have to factor it, but it should be techniques we're familiar with. And then the last possibility, if we can't factor it or it's not given to us factored, we're going to have to use technology. Which means I'm going to jump into Desmos and I'm going to use the graph there to help me create this picture. Okay, so let's kind of go through examples of these. And then we'll look in the next section. Sorry, they put a little sentence here. Other techniques found in the next section. So we'll look at other techniques later, but for right now, this is what we're going to focus on to kind of build to where we're heading. Okay, so let's say we want to find the horizontal intercepts of this one. Okay, so we weren't lucky enough to get something weird, but we can probably factor this. So let's give it a try. I notice that each of the terms have an x squared in common. So first thing I'm going to do is pull out a GCF of x squared. And I'm left with x to the 4th minus 3x squared plus 2. Okay. Now, even though this is not a quadratic, we can factor this as if it was a quadratic. So this is going to factor into x squared times x squared. That's the first 2 terms, right? Because I got to multiply to be x to the 4th here. Sorry, that's the GCF right there that we brought out. That's that x squared. Okay, those 2 x squared are a direct consequence of that x to the 4th. Now I'm going to, I know that the last number needs to multiply to be 2. So I'm going to write 1 and 2. And since it's going to be a positive 2, that means they're either both negative or both positive. But I notice the middle term is negative, so these are both negative. All right. So this is factored. I'm going to go ahead and erase all the extra stuff here. All right. So I'm going to set this equal to 0. Because that's what you do when you find the horizontal intercepts. You set f of x equal to 0. Okay, so this is all equal to 0. So let's just set each piece equal to 0. So x squared equals 0, x squared minus 1 equals 0, and x squared minus 2 equals 0. Okay, so x squared equals 0. I'm just going to take the square root of both sides, but it's basically just 0. Really didn't need to do that. It's not very exciting. Next one, I'm going to add the 1 first. Then take the square root of both sides, and that's going to give me plus or minus 1. So I take the square root of 1. It could be either positive 1 or negative 1 that squares to 1. Okay, same idea here, only this time it's not going to come out nicely. Oops, I'm a little too fast for my computer. So this is going to be x equals plus or minus radical 2. And there are the 5 horizontal intercepts. All right. And that's it. I'm done. I'm not going to, unless they ask me to list it as ordered pairs, I could, but I mean, I've solved all the values for x. Makes sense, by the way. The most I could have had would have been 6, right? Because the degree of this polynomial is 6. And so the most I would have had was 6. So we're good. Okay, let's try another one. Oh, nice. This one we got lucky. So in this one, we actually have it factored for us. So I'm just going to set it equal to 0 then. I'm setting g of t equal to 0. And I noticed, by the way, that they asked for both the vertical and horizontal. So I'm doing horizontal first. So I'll set these two pieces equal to 0. Now, technically, I don't really need to set the t squared equal to 0, right? I mean, because I'm going to take the square root of both sides and it's going to go away. It's kind of like the 0 was in the last example. So square root of both sides, fine. I could have just jumped right to saying t minus 2 equals 0. It would have been completely reasonable to jump to that. Okay, and then that's going to give me t equals 2. There's 1. Okay, over here, minus the 3. I don't know why I'm showing that step. Negative 3, divide by 2. So I'm getting negative 3 halves. And there we go. So there's our horizontal intercepts. Now let's do vertical intercept. For the vertical intercept, that's when we plug 0 in. So I'm going to plug in 0 for t. So I'm going to find g of 0. So that's going to be 0 minus 2 squared times 2. I'm sorry. Yeah, times 2 times 0 plus 3. Okay, so that's going to be negative 2 squared, which is 4, times 3 comes out to 12. So the vertical intercept is going to happen at 12 or 0, 12 if they want it as an ordered pair. And then the horizontal intercepts would be 2, 0, and negative 3 halves 0 if they want those as ordered pairs. Okay, otherwise, if they don't ask for the ordered pairs, we can just put the values that we just did. All right, moving along. Okay, so this one, I see I have 4 terms. So there's really only one thing I can do with 4 terms. First, I check for a GCF, and there isn't a greatest common factor. But then I might try factor by grouping. And with factor by grouping, that's when you group the first 2 terms and then group the last 2 terms and you try to factor. The first 2 terms I can factor out a t squared, but what I'm left with, t minus 4, if I factor, well, I can't factor anything out of the second group, I can factor out a 1, it doesn't match. And these have to match in order for this to factor by grouping. So can't do that way. And therefore, I'm going to go ahead and use Desmos. So let me go ahead and jump into Desmos really quick. I'm going to share that. And we're at the graphing calculator. And here I'm going to attach my keyboard to make my life a little easier. I'm going to enter the equation. And I'm going to enter it exactly as is. So we have... Hold on, I all of a sudden just blinked and wanted to make sure. Yeah, okay, it is h of t. Sorry. Okay, h of t equals t cubed. So I'm going to use the raise to button, which is the caret symbol, which is shift 6. And then plus t, 4t squared. So I'm using the raise to symbol again, and plus t minus 6. All right, there we go. I felt like I was stumbling over it. There we go. Okay, cool. So from here, I can see that the it's crossing at 1, negative 2, negative 3. And I also see a vertical, sorry, I'm going to cough here, a vertical point right here at negative 6. It looks a little bit off because there's like, they're identifying a low point right next to it. So right next to that is a low point, just a smidge over. And then there's a high point in between the negative 3 and the negative 2. Okay, so I'm going to go ahead and roughly sketch this then. Let me go back to my notes. Attach the keyboard here. All right, so roughly sketching this then. So if you use Desmos, I usually expect a slightly rough sketch, though we're going to look at some techniques in the next section that will help us a little bit differently. We will be using technology, the Desmos, but we're going to use it just a little bit differently here. I'm going to kind of give myself a little bit more space down below. 1, 2, 3, 4, 5. There's -6. All right. So we had -2 and -3, and then also at 1. And then it went through -6. Okay. And then if I draw this, it went like this, and that kind of hit a high point between those, and then it hit a low point right next to this. And then there we go. That's the rough sketch. Okay. But now I can see that there are horizontal intercepts at, here, I'll write it out both ways. So at t equals -3, -2, and 1, or I could do -3, 0, -2, 0, or 1, 0, depending on if they want the ordered pairs. And we could verify that those are in fact the intercepts if we want. If for some reason we're unsure, we could plug them in and make sure we get 0 when we plug in -3, -2, and 1. Okay, so we're going to kind of do a little bit more exploration with this. And looking at this function, as you can kind of see this graph here, very given us here. The first factor, right, x plus 3, that's going to occur right there at -3. And then at x minus 2, that's going to be at +2. And I notice that the graph actually kind of bounces off at 2. See that? Well, that's because of the fact that it has an exponent of 2. The last one, x plus 1, that occurs at x equals -1. And right there, we see that the graph actually kind of mimics a cubic function, which makes sense since it's a cubic. So if there is an exponent on the factor, which means that the factor is occurring more than once, right? Really what this means is, if I wrote this out, it would be f of x equals x plus 3 times x minus 2 times x minus 2 again, times x plus 1 times x plus 1 again, times 1 more x plus 1, right? That's what that means. It's how many times it's occurring. But the more times it occurs, it actually affects the way the graph looks. And we call those multiplicities. So at the factor of x plus 3, right, or x equals -3, that one has a multiplicity. I'm going to abbreviate that MULT, multiplicity of 1. At x equals 2, that one has a multiplicity of 2. And at x equals -1, that has a multiplicity of 3. And it mimics different behaviors at the different multiplicities. So I went ahead and grabbed from the book mapping of those behaviors. So the author calls the power p, and when p equals 1, that means we have multiplicity of 1, right? Multiplicity of 1. It crosses right through the x-axis or the horizontal axis, whatever the axis is. Crosses right through. If it has a multiplicity of 2, it bounces off kind of like a parabola. And if it has a multiplicity of 3, it goes through kind of like a cubic. And they make a mention that with even powers, it's this bouncing off thing. But with odd powers, we start seeing this like mimic of the x cubed graph, but they start getting flatter and flatter, which makes sense when we looked at like x to the 4th and x to the 6th. They kind of look like x squared, just a little bit flatter. Same with x to the 5th and x to the 7th. They look like x cubed, but a little bit flatter. So they're just kind of making mention that's visually what we expect to see. Okay, so let's use this idea to try to draw a sketch of this graph. Now that we have all this information, all this understanding, let's draw a sketch for the graph. So first thing I'm going to notice is I have 2 factors kind of already set up for me. And that means that I have horizontal intercepts at x equals -3 and x equals 5. And I'm going to go ahead and make a note here that at -3, that one had a multiplicity of 2. So I'll just denote that p equals 2, just to squeeze it in here. Sorry, that's like a sad 3 and it's driving me crazy. There we go. Fixed it. Okay, now I'm going to go ahead and really quickly find a vertical intercept, which means I'm plugging in 0. And that's going to be -2. So I'm going to go ahead and skip to, rather than showing 0 plus 3, I'm just going to actually add 0 plus 3. That's going to be a 3 squared. And then 0 minus 5 is going to be -5. Okay, actually, that's going to be kind of a big number. That's going to come out to 90. All right. So the vertical intercept is at 90. All right, so we'll make an adjustment on our graph for that. The next thing I want to notice is that the degree of this polynomial. So when I look at the degree, I'm looking at how many x's I have. Now I have this x, but it's a multiplicity of 2. So technically that's x squared. So there's 2 x's right there, and then there's an additional x. So this thing is degree 3. And with degree 3, we know it kind of has n behavior similar to the cubic function. So it's going to go in opposite directions. One's going to go positive and one's going to go negative. And I know which one it's going to be because there's a negative here in the front. Oops, sorry. My program bugged out there for a second. There's a negative in the front. So that means it's going to mimic the negative x cubed function, which means as x goes to positive infinity, this thing is going to go the opposite. It's going to go to negative infinity. All right, f of x is negative infinity. And when x goes to, I keep throwing equal signs in there. I keep doing that. When x goes to negative infinity, f of x is going to go to positive infinity. All right, so let's do a rough sketch. So first thing I'm going to do, the x-axis, I'm going to keep it pretty standard because these are pretty small numbers. I'm just going to make sure I go out to 1, 2, 3, 4, 5, 6, 7. So I'll go out to 7. 3, 4, 5, 6, 7. Okay. So there's +7 and -7. But on the y-axis, I'm going to instead, because I have to get all the way up to 90, all right, I'm going to actually go by bigger numbers. Now, I kind of have a rough idea of what this is going to look like. So I'm going to go ahead and go by 20s. So 20, 40, 60, 80, 100, 120, 140. So I'm going by 20s. So that's -80. All right, there we go. I've kind of given myself some labels. And I'm going to go ahead and graph this thing. So at -3, right there. Such a sad looking 7. Sorry, I just realized how bad that 7 looks. That's a -7 right there. Okay. At -3, the graph is going to bounce off there. Okay. At 5, it's going to cross right through. Oops. Sorry, let me switch back to red. Sorry, at 5, it's going to cross right through. All right, it's also going to hit 90. So 20, 40, 60, 80. It's going to be between 80 and 100. So there's 90. It's going to hit there. And I know that in the negative direction, right, as x goes to negative infinity, the graph is going positively. So here's what's going to happen. The graph is going to come from this direction because it's going to the positive infinity here. It's going to bump this. It's going to come back up here, probably cross through here somewhere, and then loop back down and then go back through there. And it's just going to go straight through and keep going on to infinity. And there you go. It might be a little bit shaky just because this might go a little bit higher. This curve might jump up a little bit higher here. It might actually, I might have started curving a little too soon. Might have gotten something more like this. Ooh, there we go. Trying to make it look a little bit more natural too, the shape. But that's the idea. I got the big key points in there. and it's degree 3. It looks like a negative cubic, and that's how we would do a rough sketch with this information.